So ready to jump into the Hive session? Should we start? Great. All right. All right. So let's jump in. So the recording has been started and great. So we talked about a general introduction about why do we need Hive. Hive basically gives you the SQL to churn your data, and that is like very important thing. So because there are in most of the cases people end up churning a lot of data using SQL alone, and lot of work gets done using SQL only. Okay, so in industry almost all senior IT professionals know SQL, and therefore providing an SQL interface makes a lot of sense for any tool. Okay, now imagine this: instead of writing MapReduce, all you need to do is write a SQL command. That's all. In case there is a custom need requires, you can write Java function for that. For the rest of the things, you can continue with the SQL. Okay, let's jump in. Let's jump in. Okay, so right now, these are the limitations. So did we talk about limitations last time? So limitations is that using Hive, you can query the data easily, but right now the record label update, insert and delete are not required. This is being solved in version number 0.14, which is coming up next. We are using 0.13, in which it's not available yet. And it can generate the tables as of now, but it can't do update or inserts as of today. And it is not suitable for OLTP because queries have higher latency. It takes some time for the boot up. This is also being resolved in 0.14 because they are trying to solve the boot up time, bring down the queries to below 1 second. Okay, below 1 second. So that will make the life really, really easier. Okay, now so those are the limitations, but some of the limitations are being taken care of in the next session, in the next version. Okay. So it is important to note down the architecture of Hive before we jump in. The current boot up time is above 1 second. Okay. Current boot up time is above 1 second. Okay. So in Hive, you have CLI, which is command line interface, and then HWI, Hive web interface, then JDBC, and then ODBC, and then thrift service. Okay. So whenever you are building a solution as a general practice as of today, if you are building any product and you want to provide interface to lots of programming languages, right? So let's imagine for a minute that you are a service provider such as Wikipedia. Now lots of people want to query your data. So what will be the single best interface you can provide to the users? The programming interface. What will be the best you can provide to the users? Anybody? So you are a service provider, and people need to query your service either manually by the way of browser, or they might be querying using their own programs. They might be querying using Python, Shell, PHP, Perl, and whatnot. So what will be the what should you be writing? I mean, how should you be building your service? Anybody? Anything, just give me anything. So you're building this nice service. All it does is it provides people certain information when they query about something. Okay. So what will be the best way to provide such a service? Through the browser. Excellent. That is called the REST-based interface, where through the browser people put the values in the URL when they want to read, and when they want to change something, they make a post request, and that is called REST interface mainly. So in Madhav says it should have a server on which others can interact. Okay, okay. Now imagine that we want to provide the interface to various programming languages. What are the things you would do? Service oriented architecture. Good. Service oriented SOA is, yes, that is the thing to go forward. But which particular service oriented architecture do you quickly pick up? SOAP. Okay. Okay. REST. Okay. Okay. So these are general architecture and programming talk where what kind of service architecture would you use? If you use a simple REST based service, then when you are making a call from a program, it will be a stateless call. As well, sending a complex structure of object would require parsing and would require forming that object back and forth, right? Now, if you use SOAP has got lots of XML, and the transfer cost is a little too high. All right, create an API. Good, but in what language will you create an API? There are at least thousands of languages. For which client will you create an API? You are a global service provider. So I will choose something close to SOAP, just that a little bit thin and little bit faster. And in those cases, I'll choose something like a thrift service. Okay. Thrift service basically lets you write the service in an intermediate language. And when you compile this intermediate language, it will generate hundreds of clients and also generate a server which you can modify to fit to fit your needs. Okay. There. Okay. And that's a sort of a industry standard when it comes to building an open source service. And Hive service itself is basically a thrift based service which you can call from. All right. So we were talking about thrift service. So whenever you are building any service, you generally build a thrift service, and basically it's an intermediate language. You write all of your definition of the API. You write all of the definition of the API in this intermediate language, and that gets converted into all kinds of programming languages. All right. You will notice a lot of thrift servers. So every service, whether it's command line, whether it's, you know, all of this will be calling the drivers, and JDBC, ODBC, all of they will be converting internally to the thrift service, and then will be calling the driver. Okay. So basically Hive makes it possible that people should be able to make calls from any kind of programming language, right? Just because of thrift service. All right. And here is the one which basically takes your SQL, compiles it. What does it mean by compiling? Converting it into maps and reduces, and then sending it to the Hadoop. Okay. And there is this meta store. Basically, whenever you are creating a table using Hive, some of the structure or schema of a table is stored in metastore. All right. Now let me. Okay. So before the further delay, let's have a look at what this guy is doing. So again, sticking to the same philosophy, just like we had written a hello world program of word count using pig, it's a similar one. This one basically makes a copy of this file as this one, and then okay. So this is basically a classic SQL. The objective of this example is okay, barring this part. So this is basically we say copy file, and this is count words using the copied file, right? So this is the classic example of how do we do the count of words in a big file. And those who are acquainted with SQL, they would be knowing what does this line do. Okay, this line basically is splitting. So now look at this. First, what we did was we created a copy of our whole text, right? If you remember the big.txt basically contains a lot of text, and we are trying to do the word count using SQL. So first thing we did was make a copy of our input file. Then we loaded that file into the copy into our table, okay, called docs. All right. Once you are done with that, once we are done with that, what we did was we splitted the, so in this docs, each line of the big.txt will come in a row. There will be a single column, and afterward you split that by space. And once you do explode is just like your what do you call, the opposite of group in pig was flatten. Just like flatten, you have explode here, and so that this w will contain one word per row. Okay, one word per row, and you can then order by one word and get the results. All right. So I'm assuming that this went little above your head, and so the objective was not to understand things, just to give you a quick idea. The objective was to give you a very quick idea that this is how your query would look like. Okay. So Hive is classic SQL. It implements SQL 92 version, and which means that all of the SQLs most likely is going to work well. Okay. So to start working on this, either you can go to the browser here, you can go to the browser and go to the Hue 8000 port, and under that there will be a Hive here. Okay, and then start executing your query. All right, or so as you can see, I just created a sample table, and let's see what happens. Okay. Okay, now nothing happened. Let's go back. Okay, select now. Okay, now select star from X and say execute. So it says there is no data available, which means there is nothing. Okay, so this is as simple as it gets. Now there are multiple ways you can execute Hive. One was using the browser, other is after you SSH you will come to the shell and either you can say Hive. Alright, it will give you the command prompt where you can type your all the commands, or if you have already a script you can execute that script, or if you just want to execute one particular query and then you can execute it like this. Alright, so this is how you get started and basically SSH to the server and start using Hive. Alright, now just to test you can say dfs -ls. Also from the command prompt of Hive you can run any Hadoop command by using dfs. Okay, if you want to load a SQL just like in in Unix, you can do source and load a particular SQL. Here you can say source and then you can. Okay, now the next thing which you should know. Okay, comments start with dash dash and it also has the same year variable kind of format where you can access these variables, shell variables as well as the other variables. Okay, and to execute a local command from here you can put an exclamation and say ls. Okay, so you can see that you just got the list of files. Okay, so here Madhav, you can actually ask this question. This is a good question, okay, to all the people, and you can say here you'll have to say dfs, okay, instead of Hadoop, this thing, and then it should work. All right, you'll have to write this way, and then file name you'll have to give. All right, you got your answer, Madhav? Good. Now the next thing is so the way we talk about any language is usual the syntax, then the data types. So the data types of Hive resemble closely with the existing databases, and these data types have been evolving time and again to adjust with other databases such as Oracle, MS SQL. Therefore, as you can see, there is a varchar which has been added, care has been added just to accommodate other kind of database queries. Okay, so data types you have, first of all you have numeric types, tiny int, small int, big int, float, double, decimal, and then you have miscellaneous type like boolean and binary. Binary and boolean is the same thing. It has been just for the compatibility with multiple kind of SQL standard, these have been included. And for string, varchar and string is almost the same, just that varchar has to specify the length, string doesn't. And char is a single character. And then date and timestamps. Okay. So these are the basic data types you will see in probably almost all the databases. that when you are defining a column can be of these either the basic data types or it could be of complex data type. Complex data type is first is array. Okay, array all of you understand, right? A list of values which are indexed by 0, 1, 2, 3. And second is maps. Maps are basically key value pairs. Okay, that is maps. And struct is basically, if you guys remember, there's a slight difference between map and struct. Struct has predefined keys. Okay, struct has predefined keys, so keys cannot change in struct. Struct and map look very close, just that in case of a map, keys can be anything, while in case of struct, you have only predefined keys, right? Now, union is something very interesting. Those who have been working in C, those who have learned C, they would understand union quickly. So, if there is a field which can which has to have multiple kind, either of the multiple values. Okay, let's say there is a field called, how should I give you an example? So so let's say there is a field called, mm, okay, let's say there is a field called city, in which either you say put false. False means there is no city existing, or you put the actual name of the city, right? So in such cases, the values can be either of the two, right? Either the binary value or the string. In such cases, or there could be multiple such values, which can either of which can come into this column. So to simplify, you define a union and say that only one value of these will be accepted in this column. All right. So each union type, as you know, that will take the amount of space equal to the maximum biggest data structure. Okay, so that is union type. So when you are defining a table in Hive, it goes like create table employees, and then you define the column data type, and you can define array, you can define map like this, and an address. Make sense to you? And then you have union. Okay, all right. So those are the data types as described in case of our Hive. Then comes the usual starting point where we say show databases. All right. So it shows you all the databases. You can create your own database using this command. Okay. We can say create ascii for the class of 7 ascii for 8 November. All right. So we have, and then to use this database, we have, we can do use. Okay. And to see what are the tables in it, we can say show tables. So it shows the tables. So these are classic SQL commands. So always, whenever you're working in your account, make sure that you create your own database. Okay, you create your own database before starting to work. All right, and there is a describe command which basically describe you anything, whether table or database. It describes. Okay, so it actually describes only the table. So create table X and we say ID and int. Alright, so we say describe X and it shows that X has got a column called ID and it is of data type int. Alright, and similarly also you can set a flag. This is a cool flag which shows you the current database as the command prompt. Now you can see the current database in my command prompt, and we can drop a database using this. Okay, don't drop anybody else's database. All right, so this is the starting point where you can start creating your databases and start creating tables. All right, now these are very standard SQL commands where we say show tables. It shows us there is only one table called X in my case, and select star from table, and we say select star from table, or let me just try to do okay, and then we have the important part is describe X with describes, and describe, if you say formatted, describe formatted, it basically gives you the detailed output of the whole in table. Okay, so it shows you in clearly that who is the owner of a table, when was it created, and where the data of this table located. We'll come back to these things. It's a managed data type. Then serialization deserialization library, what kind of library are we using there? Input format, what is the, you remember, because it is going to use the it is going to use MapReduce. So the input format is basically MapReduce text input fun, and output format is something which it completely ignores. Okay, so it shows you describe formatted is a command which you should be using when you want to understand anything about a table. All right, now on the similar lines there are so So we talked about how to create a database, see the list of table, create a table, and what are the different types of columns that can come in the table. Now let's talk something about which is different about Hive. Hive has got two kinds of tables. One is internal table, the usual one, create table X, actually created manage tables, and then is something called external. There is only minor differences between the two, but that makes a lot of difference. So when you are deleting a managed table, the data gets deleted. While you are deleting an external table, the data doesn't get deleted. Okay, external table is good in case you do not own the data, in case your data is not disposable. All right, so in case it is somebody else's data, whether local or remote, okay, in those cases you always use external table. In case it's your own data and you are okay if the table gets deleted, you are okay if the data gets deleted. In those cases you use the usual managed tables. Okay, but as a practice, if you are churning a lot of data, like in case of our big table, we could have basically created an external table when we were doing a word count, because we are not, I mean, we are doing just a read only operation. All right, so therefore it is good to create an external table so that you do not delete the data. All right, so life cycle in case of managed tables, the life cycle will be managed by Hive, and data is stored in the file you added. Okay, all the tables which we have created have their data is being managed by Hive, and all the tables which are external, their data is being managed by the is not managed by Hive. In case you drop an external table, it will not delete the data. Yes, external table is similar to views, but don't confuse with views because there is something called views in Hive as well. Okay, so all right, they are like just like any other tables, just that when you drop a table, data doesn't get deleted. All right, now let's try to see if we can do this. So external table looks like this. Create external table if not exist called stocks. Okay, and we say that this is where my location is going to be. All right, this is my location is going to be. So that is how you define an external table. You define all the columns. And also note this syntax. It says row format delimited fields and terminated by /t, which means fields are separated by tab. Okay, fields are separated by tab. And the location where when this table is going to get created and you load the data, this is where your data is going to go. Okay, so if this table already exists, then create table will essentially be pointing to this location. And let's say, let me show you this part. And so I say dfs ls asgiri. Sorry, I need to put dash. There is no need of putting exclamation. So do we see? I think. All right. So we have a New York daily file in the data folder. All right. So let's say this. Okay. Now this basically will be essentially. All right. So let's just make it the absolute URL instead of making it user student and cannot recognize the input. Okay, I'm sorry. Let me just copy paste somewhere else and start working on this. User, student, and that's all. Okay. So what does it say? It says that user, student, file already exists. Okay. Okay. Basically, you do not. Okay. Okay. So whenever you are operating on some data, when you are operating on some data which is not owned by you, okay, in those cases you create external table. All right, it's as simple as that. Does Hive support constraints like primary key, foreign key, unique key? Not yet. Not yet. Okay, not yet. Hive doesn't support that, but in next version they are trying to make all of the transactional properties and RDMS properties, those constraints to be in place. Yes, you're right, Vishal. So it will be used by some other DBMS also. Okay. So what does it say? Okay. So let me just try to create it at some other location. All right. Now, if you see select star from this table stocks, so there was already a file lying there. All right. There was already a file lying over there. All we did was we took the input data and loaded it. That's all we did. Okay. So we said create external table if not exist called stocks, and then defined all of this information and loaded it. Okay. And I think we are loading a different wrong file because that doesn't have all these columns what we are trying to do. DFS minus ls and slash data. Okay. So if we say DFS minus cat slash data slash nyse underscore daily, and we say, and also note that in this case that for each table, not fs, it has to be ls. So each of these tables have basically a directory. So we defined NYSE daily. It's a basically a directory that is the location of this. Okay, inside this directory will be your data. Okay, so whenever we say table, the data is actually going to be located on HDFS somewhere. So this location in whenever we are creating internal table, external table, whenever we say location, that's where the table is going to be stored. Okay, so that's what we demonstrated over here, that so these are the data which was already there. All right, and this we try to map with this table. Okay, it's of course wrong, but because this data is from a different, it has different number of columns. Okay, but it has loaded somehow. One, two, three, four. First four columns have been loaded like that. All right. Okay. So I built in the definition. Where do we specify? So we created the table. We said create external table called stocks if it doesn't exist. Okay. So this is how you create a table with an existing data. If it doesn't have data, then you can use, I'll show you this command. Uh, okay, external. All right, so I think I should take you through the whole process. Okay, right. So let me just describe this once. Let's say I'll take a very simple example and show you how do you churn the data, and you will, Cletus, you will get a clarity on what does it mean by internal table, external table by the end of this example. Okay, so let's take a very simple case. We have got a file called the employee. All right, this file has got three columns: name, and say years, and degree. All right. So we have to load this data into our table so that we can do the churning. Okay. So let's say create table my emp. Okay. And we say name, and name is what? A string, and years is an int, and degree is a string. Okay, these are the three columns as you can see in this file. It's a comma separated file. So I've just created this table called myamp. All right. Now if you see, if I say select star from myamp, there's nothing much. Okay. So how come? All right. Now we've created this nice table, and now if you see select star from myamp did not give anything. Now, as I showed you that the amp contains the data, we want to, yes, it will give an error, and it does try to cast. It does try to cast, but it'll most likely it'll going to give error. It can't cast. Okay. If it is integer, it can convert it to a string. But if you are trying to say this column is integer and you are trying to put string into it, it will give an error. So right now yeah, I made a mistake, Srikant there. Thank you for that. I basically created the table into the default database. Ideally, I should be saying use my database. Right now, we have got this table called emp. Now, what we need to do is load my data, load data in path. If you say local, it will be picking the file from the local system instead of HDFS. If you don't say local, it will pick up from the HDFS. Right now, our table is existing in local file system. Okay, and I say into the table called, what was the name? My emp. Okay, now let's see if what does it say. Okay, I'm not supposed to put single quote over here. So there we go. So it says copying data from this file to HDFS, and after that it has done the job. Okay, afterwards it has done the job. Now let's have a look at whether the data has been copied and loaded into my emp. You see, now the data is loaded. The only mistake what we have done is we have not specified the splitter. So each of our line is actually loaded onto the first column itself, and the rest of the two columns are null. All right. So that was a mistake. So let's say delete from my emp. Okay. Okay. What, oh, delete we can't do. We'll have to basically drop the table, drop table my emp, and then create it again. Okay, here we say that we when we load it, we say that row formatted. Okay, oh sorry, again. Okay, so we say here load data. Okay, first we need to define the table again. So I have to define the table again, create table, and then we say row formatted and delimited fields by comma. Okay, now if you load this data, load my local file into the table called myemp, and that's all. You don't have to define the format here. It will load the data. Now if you see, select star from myemp. Okay, select star from myemp and you are happy. Alright, now you can see that it's not null the other columns, and it has figured out parsed. Right. So if you basically load the way this way we are doing, Madhav, it will basically keep on appending it. You can see it is basically appending it, right? But if you say load this data into this and we say overwrite. Wait. Okay. Now if you see, it will be only these two rows. All right. Now we were able to successfully load a local file into this table, and now what all we can do? We can say select sum of my years, or let's just check the describe my emp. Okay, so you have got years in this, and if you say sum of years and from my emp, let's see what happens. All right, now you can, as you can see that for this also it is trying to create MapReduce. So can we use multiple delimiters, example space and tab together? The answer is no, because that's how this default one works. But in case you get stuck into that kind of scenario, you could use regular expression split. Okay, so it is called regexp search. I will show you that one. Okay, it's called regexp search, where you could basically use regex to parse the whole row, load the whole row as a single line, and afterwards you use regex to pick up elements, right? So as you can see, okay. So Madhav, so you want your question to be answered, or you are asking for something else to explain? Will you explain the process behind what's happening when we load a data into table? I mean, if there is a MapReduce job started, what if there is a very large file? Very good point, Madhav. Thank you. So first, whenever we load the data, it basically tries to import it into the file system. Okay. Now, the standard way of importing data into Hive is, in case you are really handling a huge data, is first move that using dist copy into HDFS. Now, dist copy will ensure that the movement of your data is really smooth by using all sorts of data nodes parallelly, doing all sorts of tricks. It will make sure that movement of your maybe hundreds of GB of data is really, really fast. That is first thing. Second, once you have moved the data, you will use the load command. You will use the load command to load the data from HDFS. Here, we used we use the load command and we said local. In case we don't say local, then it will try to find this file in the HDFS. All right, it will try to find this file into HDFS instead of local file system. And that is how you handle So most of the map reduces in those cases, this file movement is going to be taken care of by this CP. All right. So it will do all sorts of map reduces to copy the data from local file system to the HDFS, and then you use this. The load command of Hive, this local one, is not really a great candidate for moving or copying the file, because it will basically will not be using all the techniques that dist copy uses. All right. Okay. So was I able to explain, Madhav and Vishal? Vishal, your question? Should I repeat what I was talking about? Okay. So in case your data is quite complex, okay, so if the file is loaded on multiple nodes, will there be a separate load on each node? Yes. So no, you don't have to do a separate load. All of that is actually very well taken care of by Hive. Okay. I- So you don't have to worry about whether the amp file, when we said load here, is on multiple computers or a single nodes. Okay, it will be taken care. As long as you have removed the local from here, it will be happy to do that. Okay. Now, this load, what we just talked about, load a file, will basically load the data by moving. In case this file, it's a little tricky. The EMP file, if it was loaded on HDFS and we said data load data in path instead of mentioning local, it will move it always. It will move this file from there to the location where your file is located. Okay. Now I'll show you something. Now we have got what? Select star from the EMP. What is the table name? Okay, my EMP. So we have got this table called my EMP, and we have just loaded the data into it. So there would be somewhere it would be storing it, right? So Hive under the hood creates a directory for my EMP. Okay, and where is it located? Let's have a look. So if you go to either the browser or somewhere, let's show you in the browser itself. Okay, go to the file browser. We are browsing HDFS right now. We could have done from the command prompt as well. Let's go one level up and then further one level up. Now here you will see apps. Under apps, there is a Hive directory and there is warehouse. So every table you create, if you do not mention its location, you while creating a table, you can also mention where do you want to create this table. You can mention that location. The way in our previous example, over, not this one, not this one. Yeah, in this one we mentioned that my location is here. Okay, we mentioned that. So if you do not mention the location of your table, the where is the data going to this table, this location means this is where the data for this table is going to be located. If you do not mention this, it is going to create your table under this folder called apps hive warehouse. Okay, now let's have a look at our table. Where is our table? My emp. So for each table it creates a folder, and under that folder all those files which you are moving, whatever you're copying, will be done here. So you can see this. So it contains those that data. Okay, it contains that data. So Madhav's point is that Probably Hive doesn't support update because we don't have an option to add content to an existing file in HDFS. Partly true, and partly the other reason is Hive is mainly oriented towards churning the data, right? If your statement could have been 100% true, then HBase is the database which runs on top of HDFS. HBase will also not be able to provide you an option to update the content, but it does, right? So it's more about an architectural decision. It's definitely possible to, create a new block and make a append only kind of structure and still provide update and deletes perfectly well. Okay. So it's just the architectural decision of Hive where its objective is to basically convert the data into row wise. Okay. Its objective is to churn the data. All right. So now you can see that my emp directory contains this data whatever we copied. So every time we copy over here, every time we copy the data into that. So if I don't use overwrite, it will basically copy again. And now if you go back to here and refresh the page, you will see, okay, here, hold on a second. All right, let us have a look. So it has must have created two files. Yeah, it has created two files of the same in this folder. Okay, under the hood, this is how it is storing the data. While here it gives you a very nice, neat interface. Select star from my EMP. Okay, now you can see that. Now on this, you can do all sorts of churning. You can say group by group by what do you call degree. Okay, degree, and you can say sum of years, and then we can say degree. Okay, those who are familiar with the map and reduce, they will quickly, so those who are familiar with the SQL, they will quickly realize that I'm trying to do a group by on the third column and then sum up for each of the degree the values of this one, right? So that is something interesting. So now you can do all kind of churning without having to write a single line of code or compiling anything. It's doing everything for you, just like pig. All right. Okay, so we, right, perfect. For B tag there is 20 and for MA it's 18. All right. So any data you have, you can load that data into a Hive table and then start processing it. Okay. Start joining the two tables together. If you have two tables, you can start joining them together and then do all whatever you did with the SQL, you can do that here, except for inserts and updates. So any churning you want, joining two tables, creating a view, and everything can be done using Hive. Okay. All right. Is everybody comfortable till now? And like for example, if I have to pick up here, I can do so select star from my table, my EMP M1, comma my EMP M2 on M1 dot degree where M1 dot degree equals to M2 dot degree, or we can say not equals to. All right. So now you can see that I'm trying to do a self join and trying to do all of this using, yeah. Happy? And before that, I'll also like to highlight, which I have not included in this example. There is something called regex regex extract. Okay, so that's also a very useful feature where you can load the whole row as, okay, so I'll just show you, right? So if you have loaded the whole row in the first field, now you can do regex extract, right? And then the 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 column you want to put, that is the first parameter. Second, second is the pattern, and under that pattern there could be brackets. And index is that nth bracket. You remember the when we talked about, so let's say there is a file, there is a content file, as Vishal told, that Sandeep space Giri, and then we have tab uh, age. Okay, we loaded this file into a table which has name and which has age. Now we want to create a different table with first name and last name and age. Now, how would you do that? How do you translate? Basically, given this kind of a table where there is a space and there is a tab, we want to load it into this kind of structure, right? So let me, all right. So here you can see what will you do in this scenario. First, you created this table, then loaded your file. This is your file. Load your file into my first table one. Okay. Now, after that, what will you do to for converting this into this is select regex extract, and I'll call it name, comma. Now I'll say those who have attended the regex session, they should be able to correlate with this one, and I will say 1. So this will basically give you the first one, and this will give you the last name, and then you say age, and there you go. You got the result which you were expecting, whether you want to insert into somewhere, or or you want to just print it. All right. So so Vishal, this was clear to you? No? I said regex extract, and then the name of the person. Okay, the name of the person from the table 1. Table 1 has two columns, name and age. Name has got full name. Now match with this pattern, this, and capture these brackets, out of which pick up the first one, which will be going to be first name. Similar is the case here. Make sense to you? Here we are just picking the last name. All right. So that is interesting because we will be talking about it when we do the sentiment analysis in one of the sessions. We'll be loading the Twitter tweets. First, we'll download the Twitter tweets using a component called Flume, which downloads the unstructured data. And after we are done with that, we will use this kind of syntax in Hive to join that data and prepare the sentiment analysis. All right. So, so make sure that you try out all the things which you have doubt in, Okay, before we move ahead. Okay, now let me answer Madhav's question. Is there any option? Let me just note down few points. Is there any option to close these warnings and informal messages while querying? Suppose we want to store the so while you're storing, right, these errors will not come as such. Okay, say if you have said select star from my EMP. Okay, so here let's just try to save this output somewhere and then see what happens. So basically all these warnings are being displayed to stder, right? S- Therefore your output file will be clean. If you want to store, then that is anyway handled very well. All right. So I stored the output of this command which I just executed into the file called output, and then I printed the what was inside it. All right. Is everybody with me? So warnings will come, but they will come on std error. Every time whenever you have these command prompt, whether on Windows or Linux, you have two kinds of output devices. One is stderr and other is stdout. Okay, so all the error messages and warnings, they are generally printed onto stderr standard error output device, and output goes to the output. So when you are doing a redirection in general, only the standard output will go into the file unless you forcefully do it. All right, but there would be an option to suppress. If you see Hive help, there should be some way to suppress all the errors. All right, now there is something called a partition table. Good. Hive minus s is for silent. Good, thank you. Now there's something called partition table. So more often than you can expect, when you are dealing with big data, your data you would like to store in multiple files, or your data might be located in multiple files. Okay, or multiple folders. All right, so we had this file called DEMP. Okay, and we have this, let's say, a table which we are saying that partition this table by a parameter called qualification. What does it mean by partitioning table? Right now, all the tables which we are creating, they are being stored in a single file, right? In case we want to store forcefully into multiple files based on a parameter, in those cases, partitioning really helps. Okay, partitioning basically makes it possible to quickly look up the data. I'll show you how. All right, so let's take a case of our usual file. We have got this demp example. It is a tab comma separated. Now we create a table. Let me just open up 2 3 consoles. All right, so we have Hive. In one console, I have opened the command prompt. Okay, this may command prompt. And in another, we have got Hive. Okay, so first, let's just create this table called employees table. It says the table already exists. Let's just drop the table. Drop employees, right? Now let's just create it again. It's created. Now, as soon as you create it, you should see under warehouse, you will see a table called employees. It is empty as of now. It's recently created December 26, 8:29 a.m. All right. Now, once you have done that, let's import. We have saying it has got 3 columns. Let's just see describe employees. Okay, let's see what is there inside it. It says that it has got 4 columns. Fourth column is a virtual column which we will be using as like an index. Okay, based on that file we are going to split our data. Based on the fourth column we are going to split our data. Now let's try to import some data. And so first 3 columns are being read from this one, and fourth column we are providing from here. The one on the basis of which we have partitioned our data. We are saying import this file, import the amp file, local import this data into employees table and create a partition for qualification equals 1. All right. Similarly, we are going to import, I think I should basically try to modify. Let's do, I'm just trying to create another set of data for second one so that we have a segregation. I'm going to put 2. All right. Now we have got 2 files, the amp, and the amp contains this. The amp one, uh, why didn't I save it? Okay, it became opposite actually. Okay, all right. So we have got, okay, I'm sorry. All right, so we have got the amp1, which is our new data in which we have changed the names. Now we want to give it another partition. We want to give it another partition. So we'll just create another partition for this new file where our, all right. Now if you do select star from my emp, you'll see this. Okay, not my emp. Am I doing something wrong? It is employees. Okay, so select star from employees. What does it have? Nothing. Let's import the first data. Select star from employees again. Now it has this one, and it says that the for there you see the fourth column, that is the one on which we are doing the partition. All right, now let's do the second one. Let's import the second data, and now let's have a look at select star from employees. Now you see there are, fourth column is different. Now if you say select star from employees, where quali qualification equals 2. Okay, now it only has to look up into the second file. That is why it did not do a map reduce. Now what did it do under the hood when we basically created two partition 1 where qualification equals 1, that came from one file, then second partition where qualification equals 2, that came from the second file. What it did inside is it created, all right, so it has two folders now. Okay, qualification 1, qualification equals to 2. All right, that is what it means by partition. So it has the first set. Now if you go into one level up and go into the second one, then you will see this. All right, so basically partition means the physically there are two set of folders. All right, and you can create partition based on multiple columns. In those cases, for each of the distinct values there will be each different folder. All right, and you can take the benefit of partitioning when you are executing queries like this, where you are only bothered about one section of the partition. Your output is going to be really fast. All right, so it sort of works like an indexing for you. It sort of works like an indexing for you. Make sense to you? No. Madhav is okay. Shrikant is okay. Did I confuse you guys or should I explain something again? So basically, the concept about a partitioning is that the whole table we do not want to store in a single file. We want to store some rows in one file, some rows in another. And how do we do that? Okay, on what basis should we do this? So we basically parameterize it such that just like indexing, it creates different buckets. We can store in two tables as well, right? Yes, we can also store in two tables. Very good point, Virana. So yes. So can we load files with different number of columns using partitioning? The answer is no, because I mean you can load, but the values which it doesn't match, it will put them as null. Okay, so it's a single table. Therefore, all the partitions are going to have the same set of columns, right? Anyway, we have to write queries specific. Is there any advantage of partitioning versus using two tables? Basically, in case your data is same and you expect that you are going to query again and again, then it is better to have these two partitions. Also, if your behavior, yeah, let me again try to phrase my question. So if you have got multiple columns on the basis of which you want to create these partitions, then if you think about 100 zip codes, okay, so you want to create 100 files. Creating 100 files automatically by the database is easier than you creating multiple tables. All right, but that's, you have got a very valid point that it we could have also created two tables, right? This partitioning is advantageous when we want to drop data which are older than some date. Perfect, perfect. Thank you, Madhav. Right. But Virana's point was that we could do all of this by having multiple kind of tables, right? And then do a union or do a join on top of these tables and give the output. The only single advantage I've been able to think is having this approach is, first, same structure is not being copied everywhere. Second, it is mostly dynamic. Automatically it is doing the partitioning for you sometimes, and sometimes you have to define it. All right. Now, also there are another thing. If there are different data sources owning the data, then you don't have to worry about anything. There is a single table. You don't have to join with multiple tables. There is a single table. You keep on select star from my table, and that's all. Right. So now we have, though we have different partition, we are able to query it. And if we are saying select star from employees, and we say group, okay, and again we can say count star and group by qualification. All right. So the warehouse folder is actually a folder where the data is stored. Every time you do load, the data gets moved onto this folder. Whenever you load a file which is located on HDFS, the file is actually moved over here into this table, into this folder. If you are loading the data from external sources, the data gets copied. All right. So now you can see that we are able to run group by beautifully and get the results. It's not a symbolic link, it's the real data. It's the real data into in HDFS. Great. Move on. So we were able to demonstrate that it has created these kind of folders, and that should clear up all the doubts you have about partitioning. And there is something on top of it, there is something called external table we can create, which is partitioned. And again, the way we created partition based on our qualification, we can define partition based on year, month, and day. And Madhav, this is exactly the kind of thing you were talking about. In case you are doing a rotation of your logs, or you're doing all kind of other churning, you can create partition based on the date, right? And at later point of time, you can say that alter table and then add a partition. You can keep on adding this partition one by one, and every time the location is going to be different. And the beauty about this here is the data is not located in this case in HDFS. Okay, one partition, year, month, 2012, 2nd January. The data of 2nd January 2012 is located on this location, which is in HDFS, while the data of 2nd December 2011 is located on S3, S3 bucket. S3 is Amazon's S3. Okay, so your table is absolutely symbolic in this case. Okay, one partition. In our case, we just demonstrated that qualification equals to 1 and qualification equals to 2 both are existing in the HDFS, while in this case one partition, So we say alter table and add a partition with a location here, similarly here, right? So these two partitions are going to be located on remotely. And whenever you churn the data, it's going to hit these locations and give you the results. All right. Whenever you do the query on this table. If the data is moved to warehouse, then data file must have the right permission. Oh, yeah. So since the all of this work is being done, all of this work is being done by you, okay? So Hive is doing it on behalf of you and is creating the files, tables based with your user ID and group, okay? So more important than that is that the ownership of warehouse folder is that of Hive, okay? So whenever you do operation, the right operations are being done by the user called Hive. All right, Madhav? What if I want to load data which has only read permissions? In those cases, you should always use external. All right, external table. All right, so we were able to explain that the kind of partition can be completely external on the remote. And similarly, we can do a renaming of the table, alter table, this file, and we can rename a column. No, this is renaming the table itself. Okay, and then changing the column, we can change the column to one data type to another, change the format, and all of that can be changed. We can add more columns, so those who are familiar with SQL will not find anything new about it. Okay, the way we added a partition here, alter table, my table name, add partition based on this, and this is my location. Similarly, I can also do a drop a partition. All right, and make sure that this order of these values should be same as what you have defined. Now, okay, okay, so few notes. So we talked about all of this, and by default, if you do not provide the column separator, it loads the data based on control A. Okay, and it will create the directory for the partition, then it will copy the data. Okay, whenever you load the data, and all right. Now there are few more nodes. Each table has got some location where the data is kept. And by default, the location is into apps Hive warehouse, that is based on your configuration. And you can override the location by mentioning location for each partition or location for the whole table. Load copies the data into the table's location, or it moves the data in case the data is in HDFS. Dropping the managed tables will delete the data at the location as we describing. Dropping an external table does not delete the data at the location. Right, right. So, am I loud enough now, Madhav? All right. So, the metadata is stored onto the local database, relational database. Metadata, what does it mean by metadata? Whenever we are defining create table, this is my column, this is this, all of that is metadata. Number of columns and what is the type of column. All of that is metadata, which is data on the top of data. Okay, so that is stored in a relational database such as Derby or MySQL based on the configuration you have. All right, so that is what we have as of now. These are the notes. Then select statements. We all know the standard SQL select statement. Select A comma B from employees, and we can also give the name to the table. And we can do a computation on columns by running a function like this, upper, or we can also access the maps like this, and right. So we can do the computation in the select query. These are called projections when we talk about tuple algebra. So these are projections. So in the projections, you can do computation columns. So here, this is a new column which we are trying to create. While this is based on deductions, this is based on name, this is salary edges. Okay. Now aggregations, we have given a simple demonstration where we did a simple count star and average. And by default, there are many cases where, so let's take a step back. Let's take a step back. So when we are doing count star, what is going to happen? It's going to create a reducer which will do the count star. What if we can do count star in the mapper itself, right? In mapper, invariably, it is going to read record by record, record by record. What if we can do the count star then and there itself? Okay. So for doing that, for forcing Hive to do that, we could mark a flag called hive.map.aggregation equal to true. So aggregation will start happening on the map side itself. Okay. On the map side itself. Okay. So basically, where there are certain cases where, say for example, you have a simple aggregation like count star, right? If you had to write map reduce for this, what will you do is you will basically read record by record and keep on counting it and print it in the output. Okay. So there you would not write a reduce for it. For those kind of cases, you can inform Hive also that hey, I want the map side reduce itself. All right. Now there is something called views. You can create views on top of your database tables. Okay, and views will come very handy for you because Hive will be using mostly to churn the existing data, and while churning the existing data, it becomes very important to give the name to the intermediate states. Okay, so view is nothing but standard view. You can join multiple table and give it a name to this join, and then you can do the further processing on the view. Okay, so select create view this table as, then you write the whole thing. So in the case which we'll be dealing with, where we'll be doing sentiment analysis, we'll be doing tweets and we'll join it with time zones, and then we'll give the output. So that way you'll get the afterwards you can do a, here based on the time zones we are trying to identify the country. Therefore, we have joined the two tables, and we can simply run a select A comma B on this view as if it's a fresh table, right? It comes very handy, and syntax is standard create view syntax. You will definitely like it. Now, so that was about views. Views are quite useful. It's there is no separate file for the views. Views do not have any physical appearance other than the metadata. It has nothing. Okay, so view looks like a temporary table, but it's not. It's just this information that this view has been created on top of this join. So whenever people are calling, select star from this view, it is invariably going to join the two table and give you the results. There is no intermediate data computation. Okay. There is no intermediate data storage. The tweets underscore clean do not have a physical data. All right. Make sense to you? All right. Let me just confirm. So we have warehouse and we were. Where did it go? Actually, I just created some data. Actually, I just created some data which I had been dealing with. All right, never mind. So whenever we query view, every time MapReduce job is started for creating view and further operation. Yes, that's right. I'm just trying to figure out. I had created some views. All right. So try doing that and you will get to know that. Okay. Now, sometimes a function which is there natively available is not good enough for you. Okay. The function which is natively available to you is not good enough sometimes. Okay. In those cases, you might have to write your custom function. Writing custom function is a little um, multiple steps process, but those who are comfortable with Java, it should not be a big problem. So all you need to do is you extend a class called UDF and then you write your function name and it returns, takes text and return text. Okay. And does the all computation. Here we are just writing lower. We created a class called lower and there is a function called evaluate which takes text and converts it into lowercase and returns the value. Okay. Although lower is already available in Hive, but we have just done it in order to give you a simple example. Okay. You can create your custom functions. All right. So first of all, you extend UDF and then create a class. After that, once you are done with it, you create a jar. Okay. File export to jar. Once the jar is created, now what you can do is you can basically do add jar. Okay. Like add jar and my dot jar. Okay. And do that. Okay, it says my dot jar does not exist. If I had that created the jar, I had an example running, right? Now, once you are done that, then you create your function, create temporary function, your function name as your whole namespace dot lower. Okay, here that package name is com example hive udf, and so com example hive udf dot lower, that is your class's name, and that how you defined it. Okay, so whenever you're calling this function, evaluate of that class is going to get called. This evaluate is going to get called. All right. So when you call my underscore lower, it is going to call this function. All right, and you can use this. So this comes pretty handy for those in case you are, I mean, you're stuck and you do not know how to do something in, and Hive has not provided you a particular function. You can create your own. Okay. All you need to do is create jar file, and then do add jar and that particular file. Okay. Make sense to you? Now, I have also linked a detailed example. You can go through that detailed example. Using the same mechanism where add jar, my jar, you can do a lot of things. A lot of things. Okay. Say, for example, you want to load a JSON data. You can load that JSON data just like this. So download this particular jar, put it in the folder where you're in your home folder, do add jar and that whole this file name which you will download from here, and then you can basically create the table by using this as your parser. Okay, so say you have got a custom requirement. Your data is in custom format. In this case, it is in JSON format. JSON is JavaScript object notation. Okay. So in case your data is in JSON format and you want to load that data as a table in Hive, or there is a custom format in which this data is given, you want to load that data into Hive, you can use a custom loader provided by the vendor, or you have created your own. All right. In the same manner, add jar this, and then we said row format is given by this. All right. Is MD5 encryption supported in Hive as in SQL? If not, I can create UDF which we can change, call excellent point, Madhav. So generally people need for these kind of functions which are generally not provided by these databases. Okay. Say for example, you got SHA-1. SHA-1 is not probably provided by even Microsoft SQL and Oracle SQL, but SHA-1 is required at a lot of points. In those cases, it comes pretty handy. All right. So you can use I mean, this way you can basically add more drivers and use those. Okay. This one is quite handy. So when we'll be dealing with Twitter's data, our data is in JSON format and we'll be using this jar. You can update, you mean to say you change the column in an existing table? Yeah, you can do alter table, change column as we have shown here. Not here. y- Yeah, here. Alter table, change column. Okay. All right. So good. Everybody's good. Here, here there is this example. I want to show it to you that that we basically will download a data called from movie lens. Movie lens is one of the movie lens directory, movie lens data, where movies and who has voted how much to which movie is provided for free. Okay, so you can download this data using wget or using a browser or howsoever you want, but this is a quick syntax. I have already downloaded it. I have already downloaded it somewhere here, and I can simply say create my table. Okay, here. So I'll first, before going ahead, I'm going to basically load this particular data. Okay, let's have a look at u.data. Okay, u.data contains user ID, movie ID, and what rating the user has given, and at what time they have given, who voted for which movie, how much, and when. This is what this table contains. Okay, so as a first step, let's launch Hive, and then let's create this table called u underscore data. All right, so this table already exists, and so what can I do? I'll just put one more thing on it. Oh, that tool already exists. Let me call it 8 November. All right, I'm sure it's not existing. So we have created u underscore data underscore 8 November. There's nothing in this. Now, after, because I've already downloaded, so I have not this step actually downloads the data, then unzip it. We have already unzipped it, and this step actually shows you where your files are located. Okay, and here load the data from this location, and let me just put it u underscore data underscore 8 November, and I'm saying overwrite. Sorry, I've screwed it up. All right, now it'll load the data into my file. I'm sorry, again, it's called u underscore data. Overwrite into table. All right, so it has copied the data into my table called u underscore data underscore 8 November. All right, now we have loaded this data. Now we can basically do a lot of things from it. Okay, such as we can create, select, count of movie ID for each user ID from u underscore data underscore 8 November group by user ID. Okay, so each user has given how many ratings, that is what it will do. Okay, so in this example, you'll get a data and then you can do a lot of things with it. Is there any example of how to create a custom Saturday? I think this JSON Saturday doesn't work if I have nested JSON. Yeah, it does work actually. It does work. If you have nested JSON, you can create a struct and then load that structure into the struct. Okay. In case you have an array in JSON, you create an array column and then load. All right. In JSON, either your object will be an array or it will be an object, right? So you can create array as well as object, and both can be loaded very well. And the top level object will be considered as, I mean, its fields will be considered as columns by default. It does work actually. All right. So this has given us the information that this user, this user has watched these many movies, this user has watched these many movies, and so on. So there are people who have rated for 405 movies. Wow. That's what it is, right? Yeah, count movie ID. So there are actually people who have rated Okay, we can do a sort on this, create a view on this and then sort it, and then you can get the results. Great. So does it make sense to you? Okay, for sir, you can actually look at the little more advanced example linked at the bottom. Okay, here where you need to write serializer and deserializer both in your own format. Okay, it provides you all those details. All right. So this was a quick demo. Now, as an exercise, you guys should do is for each movie, how many users have voted it? Okay, the opposite of what we did. And for each movie, what is the average rating of the movie? Okay, and try to also load the second table. Second table in this. Second table is what? If you see, second table is movie information. There will be one table in this zip, the one which we have downloaded, containing movie IDs and movie names. Okay, have a look at that one and try to join it and try to display that for this movie, this was the rating, average rating. All right. So please go do these two exercises as part of this Hive assignment, because here practice is the far more important thing than the theory part. All right. So that's pretty much with Hive. Let's move on with the HBase now. Okay, so before we move on to the next session, do you have any questions for me? Okay. Shrikant's question is, we did not cover any installation of Hive. To install Hive, basically you just need to download the tar, just like we did for. Okay, okay. We'll make a presentation available for the next session. Good. Yeah. All right. That's a good point. In Hue UI, I don't have an option to send mail to multiple recipients. Which one are we talking about? Oh, okay, Hive querying. Try putting comma separated one. Did you try to put comma separated one? Okay, this only has email me, right? Yeah, actually that would be a little limited. All right, so we had a question from Shrikant. Yeah, so Shrikant, there's not much difficulty in installing Hive. Hive is more or less a client. Okay, it's more or less a client. All you need to do is download the tar.gz file, extract it, and then once you are done with that, you put it in a extract it, and then basically set the Hadoop home, and that's all you need to do. All right, and then you can start going. Yeah, similar to Pig, very similar to Pig. So yeah, this is the Hive client, right? This is the Hive client. When I say Hive, this is the Hive client. But there is no particularly a big user interface like MySQL's or Oracle stored. There is no such interface as of now, but any JDBC will work actually. Okay, any system which supports JDBC should be able to connect to Hive and start working. All right. What is the Hive thrift server and one application of it? So Hive thrift server is something internal to Hive. Okay, it's a thrift server which provides you various kinds of interfaces such as JDBC, ODBC in Python and in Perl, in PHP. That is the interface it provides you. Okay, just go through thrift server. Thrift server is an independent Apache thrift server. Okay, it's a completely independent. It has nothing to do with Hive per se. Hive uses thrift server. Okay, as a good practice as a developer, you should know about thrift. If you haven't studied about it, you should go and check it out once. It's actually quite powerful. All right, now let me just give an introduction to next session. All right, so should we start with the HBase now? NoSQL and HBase. All right. Okay, so let's start. So now we are going to discuss something about NoSQL and HBase. So a little bit of comic relief. So what exactly is NoSQL? NoSQL is something you can write when you don't know SQL, and you can happily say I don't know SQL in your resume. All right, and still you are expert in NoSQL. All right, so when the usual database like relational databases were not sufficient for bigger player like Amazon, they realized that they need to build they uh, players like Amazon, when they had a huge load at a particular point of time, they realized that the existing databases cannot cater to their needs and they need to build a newer kind of systems. And that's where they wrote something called Dynamo. Afterwards, Google also worked on it, and lots of other players worked on it, and they started calling these data stores as NoSQL data stores. So most of these NoSQLs are not really a great database. They are more like a data store. What is the difference between a data store and database? Database has to have lot of capabilities, such as a full-fledged query language, such as transactions, such as indexes, such as you know, the views. All there is a lot of things like triggers, stored procedures. All of that makes a data store a database. If a store has those properties, it's called a database, right? Now, so most of these NoSQL databases are basically data stores. Okay. Now, when there was a huge demand of the load, there was a huge demand of load in case of Amazon. They realized that they need to they need to build a database, and this database has got few extra properties. By definition, this database has to work on multiple computers simultaneously. Okay, it has to work on multiple computers, and it can be load balanced as and when the load increased. Okay, so when they designed, they realized that to design such a system, all of the tables, all of the database tables need to have a column called id, key or id, whatever you want to call. Every column, every table, so every table is supposed to have a column, so that if a table is distributed across the network on multiple computers, we are able to concretely say that I want that particular row. All right. So therefore, a common characteristic of any NoSQL databases is that they have a key for each row, as opposed to relational databases where it's optional. In case of the NoSQLs, it is mandatory, right? Now, there are other common properties of the NoSQL databases, such as, first, most of them are very recently developed, and they are sort of new generation databases. And NoSQL has been interpreted in many ways, but the whole story about NoSQL is that when the developers of one of the databases were rushing for a seminar, they just launched a Twitter handle called NoSQL, and that became instantaneously popular. Okay. So now people call it NoSQL, not only SQL, whatever they call, but that's the story. So basically, none of the NoSQL databases have been able to reliably give transactions as well as relational architecture. What does it mean by relational architecture? The whole CORD theorem, those guys who have read about CORD. So, ability to join two tables, ability to have a primary key, foreign key constraints, ability to have that integrity and acid properties of databases, those, none of the databases are able to provide that. Okay. N- So, by virtue of providing a distributed architecture, they are able to handle a lot of load, but at the same time, they are not able to provide relational kind of properties, as well as they are not able to provide transactional properties. And since these are new generation databases, the only way they could become popular is by making it open source and have the great adoption. Almost every distributed architecture system is built bottom up with scalability in mind. All right. So these are the few bullet points that highlight the NoSQL database. But the only reason you would be using NoSQL is basically for these three reasons. First, to handle humongous data. Third, high availability, as in, even if there is a network outage, you should have availability. Similarly, if you have millions of users coming in, still you should be able to cater to them. Users should not go empty handed. Okay. Third property of all NoSQL databases, why do we need a NoSQL, is scale out architecture. What does it mean by scale out architecture? You should be able to add more machines in sequence. Like for example, in this diagram you can see that as and when the load is being increased, they have been adding the kettles to pull it. This is horizontal architecture, scale out architecture. Had it been scale up architecture, we could have removed these kettles and put an elephant instead of that. And after that, we could have said, Ki, let's get dinosaur and then we'll put dinosaur in this if you have to pull more load. Okay, that is scale up architecture. Now, while on one hand we are able to increase cattle, on the other hand, we are able to increase the load also, right? So that is the property of all the scale out architectures. There are various kinds of NoSQL stores. I will prefer to call them NoSQL stores because not everything qualifies to be the database. First one is column oriented or wide column database. What does it mean by wide column database? They look like a table. We'll go into the details about what is column oriented with the proper example. Okay. All right. So we have got column oriented or wide column databases. Examples are Cassandra, HBase, Accumulo. And second one is document. And in the document oriented database, where we store the whole big object. Whole big object, what does it mean by whole big object? It's a hash table of hash tables of hash tables. That kind of a complex structure. For example, MongoDB, which is a document oriented database, can store the documents which are up to 100 level of nesting, right? So that's a MongoDB database. All right. As you can see in the diagram, TV shows contain seasons, contain episodes, and each episode has reviews and cast members. So if you see, it's a complex object, one containing the another, right? And that is how it is stored. Unlike a SQL database where this is broken into 6 different tables. Any questions still here? The third one we have is key value pairs. Key value pairs are the most primitive one. That's where the whole story started. Key value pairs is like a huge hash table, huge key value pair set stored on multiple computers. And we have the mapping of which key exists where. Okay. And key value ones are the most popular one. Popular ones, and the first one out of the all of these NoSQL is DynamoDB. Amazon has moved away from DynamoDB now. And then MemcacheDB. Redis is, yes, it's a key value store, but Redis has got one more property. It is in-memory database. All right. Then we have got graph database to handle complex graphs such as Facebook networks. Okay. So these are the 4 basic differentiation in the various kinds of NoSQL databases. And our HBase, which we are going to discuss, it lies under the column oriented one. Okay. So Amazon has moved to a database called Sable, which is based on DynamoDB and got many other properties. And the DB being used by Google is something on the lines of HBase. All right. All right. This is the classic comparison. Your SQL databases have been around since 1970s, while NoSQLs came in 2000s. Examples of SQL databases is MySQL, Postgres, Oracle, and MS SQL, Microsoft SQL. While NoSQL examples are MongoDB, Cassandra, HBase, Neo4j. Neo4j is that graph database where we can store the graph. And data storage model in case of SQL is relational, while in case of NoSQL, it is based on the database types. Because every NoSQL database has got its own kind of storage. Those four are the broader categories. All right. So schemas, structure, and data type are fixed in advance. So we have, whenever we are adding some data, just like in Hive, we need to create a table, define all the information up front. Okay. And most of the NoSQL are very flexible when it comes to data type. All right. Most of the NoSQL databases are very flexible about the data types and the column types. Okay. Scaling is vertical in case of SQL. What does it mean by vertical? Every time your database is not working great, you just add more hardware to it. You put more RAM, you put more disk, you put more bigger CPU. In case of NoSQL databases, they are all horizontally scalable, meaning scale out architecture. You can keep on adding more and more machines as and when required. They will rebalance and they will, cater to all the kind of loads. All right. Now, most of the NoSQL databases are open source, while relational have different various kinds of models. This is the most important point. Almost all NoSQL databases are not able to provide ACID properties. Who can tell me what is ACID properties? Quickly. Atomicity, concurrency, okay. And I for? Not really. So A, A stands for atomicity, C means C means consistency, while I for isolation and D for durability. Okay. So that is a property of a transaction. So none of the NoSQL databases are able to provide ACID properties. And data manipulation is via SQL in case of, all of the all of the relational databases, they all provide some variant of standard SQL. While in case of NoSQL databases, there is no such standard. Like for example, MongoDB has got its own way of querying along with providing MapReduce. Same is the case with CouchDB. It has got its own way of querying, while HBase kind of data stores do not have any query language. Same is case with our DynamoDB. So they have no query language as such. All right, you can only query based on the key. Okay, so almost all the SQL databases are for strong consistency, while NoSQL databases, it all depends where do they lie. So this diagram shows you the various the three pillars of the CAP theorem, or Eric Brewster's theorem. So CAP theorem says that out of consistency, availability, and partition tolerance, a database can only provide at max two. It cannot provide all the three properties at any moment of time, right? So let's take a case of consistency. So this diagram basically shows you that i- in case of DynamoDB, CouchDB, Cassandra, they can provide partition tolerant and availability. While okay, MongoDB has a MapReduce paradigm, right? The way we deal with the MapReduce in Hadoop, where we churn the data located in HDFS, similarly, MapReduce is being provided by MongoDB. All right. All right. So I'm answering to Madhav's question. Now, what does it mean by consistency? Consistency means that all the nodes in the clusters see the same data. Availability means that there is a guarantee that every request receives a response. It doesn't go unanswered or it doesn't get an error. That is availability. And partition tolerance means that in case at least one computer goes down, still your system keeps running. Okay. So this diagram basically shows you that all of these databases exist in this section, but none of them can exist in this section where consistency, partition tolerance, and availability all three intersect. And why is that? Let's just discuss this part. All right. Okay. Partition tolerance and availability look similar, but there is a difference. Availability means when people are trying to access a server, it they should not go unanswered. Okay. While partition tolerance means there is a network, you shut down any of the computer, does it harm your does it harm your data in any way? Does it harm your customers in any way? Okay. So consistency means all the people see the same data. While availability means that no matter how many users are coming, they should not get unanswered. You should be able to answer them in a reasonable amount of time. All right. Good. So now Cap theorem says that out of these three, you can only guarantee two. And let me show you how. Now let's imagine the three kinds of architectures. First one is this architecture, where you had one computer running a database and all the people, all the customers are coming to the same database, right? And being answered. This system is greatly consistent. It's greatly consistent, but it is not partition tolerant. Meaning, if this server goes down, then none of these users can get the answer. Similarly, they are not available. One user blocks the another one, and therefore the single system becomes bottleneck. Okay. Now, same way. Now let's have look at the another diagram, the second diagram, where you have two machines, A and B. A is the one where all the writes are happening. Users are writing to A, and the changes are flowing from A to B, and all users are reading from B. So nobody writes to B, and nobody reads from A. This makes sure this makes sure that, and there are multiple such machines. Just like the B, there is C, there is D, on which, but there is a single system on which the writes are happening. So this way, such kind of system is really fault tolerant. In case you delete this server, you still have one node serving you. Okay. So, and similarly, in case the first one goes down, you can start accessing the second one. You can make this second one as the primary one. Okay, so this system is greatly fault tolerant, partition tolerant, as well as it is available. What does it mean by available? That one user is not blocking the another, and in case there is a too much load of reading on B, we can put C and we can put D, where having the same kind of a replication, right? So this system is fairly partition tolerant and available. Now let's have a look at the last one, where there is a it's behaving like name node and backup name node. So name node is taking read writes, trying to do the read writes here on the metadata part. Okay, so all the users are talking to this system, and the day this system goes down, there is another system which is basically the mirror of this one available. So this system is consistent in the sense that all the users are writing to one. This system was not consistent because the second portion was not consistent because the the data one user has written to this machine takes some time to flow from A to B, right? And so they always, if the same user who just wrote the data goes to the B and says, hey, this is stupid, I just wrote the data and it's not here, I can't see those rows which I added there, this system is not consistent, right? So these systems are called eventually consistent, not because they are not immediately consistent, while the last one is fairly consistent because there is only single node on which reads and writes are happening. But it is partition tolerant. The first one is not partition tolerant. This is partition tolerant. Why? Because any one of them goes down, still people can access the data. Okay, so it's fairly partition tolerant. So is cap theorem clear to you? So this diagram tries to prove that all three is not possible in any way. All right. So that's a cap theorem. Now this is the typical RDBMS story. I have gone through this story once myself in one of the cases where we started very small and suddenly load kept on increasing really high. So initial public launch is pretty straightforward. We took the stuff from our developer machines, put it on the server, launched it, and our database schema was like rock solid. We had all perfect, you know, the indexes were perfect. We have our basic indexes, primary key, we had these foreign key constraints, we had these great triggers, everything was just perfect. So is this theorem is basically talks about mostly related to how you set up your cluster. All right, now after the initial public launch, service becomes little more popular. Lots of reads are hitting all the time, and probably this is the story of mostly most of the organization which grow face. Suddenly you start planning to put a cache, and the moment you put cache, which means that there is always a difference between the data being served to the users and the data being updated. It takes time for the cache to refresh. Okay, it takes time to cache, it takes time for cache to refresh, and therefore slowly you realize that your system is not really perfectly consistent. All right, let's continue this discussion. for tomorrow, and talk about it in more details. All right, great. So we put a full stop here today. We'll continue tomorrow. Is that okay with everyone? All right. See you then. Good night.